Here are the example questions for AA similarity. Remember that AA stands for angle angle, and it tells us the AA similarity property tells us that if two triangles have angles, two of them at least, that are congruent, then the triangles themselves are similar. We don't necessarily need to measure the third angle as long as we know that at least two of the angles are similar. Our first example asks us to determine if the following two triangles are similar, and if so, to write the similarity statement. So what we need to do is see if there are two angles that match on the two triangles. We know that there's one, angle E here measures the same as angle L, so if E and L are congruent, then we just need to find one more angle that is. Unfortunately, it looks like the two triangles have opposite other angles that are measured. Here we have our left-hand angle measured, and here we have what would be the right-hand angle of that other triangle. So let's see if we can find the missing angle on at least one of these. If we have 102 degrees here, and we have 48 degrees down here, we know that we have a total of 150, and 150 plus something has to equal 180 since this is a triangle. So that means that that missing angle over here must be 30 degrees. Now our other triangle has a 30-degree angle, so it looks to me like we have angle-angle similarity. We can go ahead and prove that other third angle over there if we want. 102 plus 30 would be 132. We know that's got to be plus something to equal 180 on this triangle. So in this case, x must be 48. So yeah, this other angle is 48 degrees. So we know for certain these two triangles are definitely similar. So then we need to write the similarity statement, and the reason we have to kind of think a little bit about that is we want to make sure that we write them in the same order. We have to make sure that we write the corresponding angles next to each other and in the same order in the similarity statement. So if we start with our left-hand triangle here, and if we start down here at the 30-degree angle, F, we can write our similarity statement as FEG, which is a triangle, and we can say that that is similar to, and then we need to sort of think what that same order would be for the other one. If we were to flip this triangle over, take this side here, it would then match with this angle over here. So this left-hand triangle would be flipped horizontally in this direction. That means that F corresponds to M and E corresponds to L. So we would have congruent or similar to triangle MLN for our second one. And there's our similarity statement. Let's take a look at example B. Example B says determine if the following two triangles are similar, and if so, write the similarity statement. So again, just like the last question, we need to find that missing angle. We know that we have a 60-degree and an 81-degree here, so we have 60 plus 81 plus something has to equal 180. So that's 141 plus x equals 180. And 141 plus x means if we subtract that 141 from both sides, that x must be 39. So this angle over here is 39 degrees. And over here we have 81 plus 40 is equal to, plus x has to equal 180. So that gives us 121 plus x equals 180. So that says over here, x must be 59. So that says that this angle here is 59 degrees. So we have one angle that matches the 81 degree, but the other two angles do not. We have a 39 which almost matches the 40, and a 59 which almost matches the 60, but not quite. So these two triangles are not similar. For example C, we have triangle LEG is similar to triangle MAR by AA. And we know that's true because we have angle E here, which is marked with 2 hashes, is congruent to angle A, which is also marked with 2 hashes, and angle R is congruent to angle G, each marked with 1 single arc. So we need to find GE, which would be this side down here, let's call that Y, and MR, which is this one over here, we'll call that X. So the first thing we need to do is find our ratio of similarity. So we need to compare two sides that correspond. So it looks like we can correspond 24 to 32 here. So if we take that as our basic ratio of similarity, 24 compares to 32, those two both divide by 8. So 8, 16, 24, that gives us a 3 and a 4. So anything on the small triangle that's 3 is 4 on the big triangle. So that can be our ratio of comparison. So now if we need to find MR, which is our variable x right here, it's going to compare to LG, which is 20 units. So we can say that 3 compares to 4 in the same way that x compares to 20. So now we can just cross multiply. 4 times x is 4x, and 3 times 20 is 60. Divide both sides by 4, and we get x equals 15. So that tells us that MR must be 15 units. And then for GE, which we've designated with a y, it's going to compare to 21. So then we can say that 3 over 4, and I'm just going to use this 3 over 4 up here because I'm lazy. Just get rid of this one right here. Say 3 over 4 compares to 21 over y. So now we have 4 times 21, that's 84. And that compares to 3 times y, that's 3y. So then we divide both sides by 3. And we get 28 equals y. So this side down here must be 28 units. And there we go.